Proof by induction that 9 to the power n minus 1 is divisible by 8. Step 1. We look at the base case. Show that the statement is true for n equals to 1. 9 to the power 1, because n is 1, minus 1 equal to 8, and that's divisible by 8. Step 2. Inductive hypothesis. Assume the statement is true for n equals k. We're replacing n with k, and you get 9 to the power k minus 1. We have to assume that that equals to 8 times p, where p is an positive integer, z is integer, z plus is positive integer, z minus is negative integer. This step will be used in step 3, inductive step. Prove the statement is true for n equals k plus 1. This is the expression again, 9 to the power n minus 1, and we replace n with k plus 1. That's where we're going, and that should be equal to, where we got 9 to the power k plus 1, we're going to use indices here, where a to the power n times a to the power m equals to a to the power n plus m. We can see n plus m here, so we're going to go back in reverse, and that's 9 to the power k times 9 to the power 1 minus 1. But from the second step, we said 9 to the power k minus 1 equals to 8p. If I make 9 to the power k the subject, 9 to the power k equals to 8p plus 1. And I'm going to replace that here. 9 to the power k plus 1 minus 1 will be equal to 9 to the power 1, which is 9. And I'm replacing 9 to the power k with 8p plus 1 minus 1. I need to multiply this out. When I multiply 9 times 8p, and I take the 8 out and put 9p here, because I need to show that it's divisible by 8. 9 times 1 is 9, minus 1, 8 times 9p plus 8. You can see 8 is a factor here. If I take that 8 out, I get 8 into bracket 9p plus 1. Therefore, this is divisible by 8. Step 4. You must write the 4-point statements to get full mark. Since the statement is true for n equals 1, and if the statement is true for n equals k, then it is true for n equals k plus 1. The statement must be true for all n greater or equal to 1. If you write all 4 statements down, then you get the full mark.